and decision making by Dr. P. Mariappan, PhD in management science as well as in mathematics too. Sir has 33 years of rich teaching experience in the field of applied mathematics, statistics, and business administration in India and the United Arab Emirates. He is working as an area chair of supply chain management and chair of academic tie-ups and international relations, St. Joseph's Institute of Management, St. Joseph's College, Trichy. He has served as head of the PG and Research Department of Mathematics, Bishop Weber College, Trichy, since 1990. In addition to that, Sir has held the position of International Relations Officer for a period of 2 years and head of the PG Department of Actuarial Science for 4 years. Also served as a staff selection committee member in many higher educational institutions in India and abroad, and hold the position of university nominee and board of studies member in many autonomous colleges, including Bharatidasan University. On behalf of the organizing committee of W AIMS 2022, we welcome you for the session, sir. The session is yours.
Thank you very much, ma'am. The slide is audible. Is it visible, ma'am? Slide is visible?
Not yet, sir.
Not it?
Yes, sir, not yet.
Is it visible, ma'am?
Yes, sir, but not in the presentation mode, sir.
What? Just 1 second, ma'am. Is it okay?
Yes, sir, you can go ahead.
Ladies and gentlemen, I welcome one and all gathered in this virtual meet to enrich your knowledge. Respected Vice Chancellor, dignified Registrar, dynamic head of computer science and chair of this program, competent co-chairs of this program, learned keynote speakers, professors, and research scholars, my heartfelt good evening to one and all gathered in this mega meet. At the outset, I'd like to thank the organizer for giving me a golden opportunity to discuss the concept of development analysis, that is data development analysis, with the elite audience, those who are present here. The title is Data Envelopment Analysis, shortly referred as DEA. Initially, if you want to evaluate the performance analysis of any sort of a company, means any industry, right, irrespective, people use the element called the financial ratio analysis. It's a quantitative analysis of information contained in a company's financial statements. Ratio analysis is used to evaluate various aspects of company's operating and financial performance, such as its efficiency, liquidity, profitability, and solvency, etc. So, to evaluate this analysis, we make use of a different sort of ratios, referred as profitability ratios. It attempts to measure the firm's success in generating income. These ratios reflect the combined effects of the firm's asset and debt management, like profit margin. The profit margin indicates the income in dollars or in rupees that the firm earns on each dollar or rupees of sales. I'm sorry. The ratio is calculated by dividing the net income by sales. That is, profit margin is referred as net income divided by sales, being the structural formula to evaluate. They facilitate comparisons. Ratios not only help to analyze the performance of one company, but also facilitate a comparison of the performance of two or more companies within an industry or a sector. The main drawback of this kind of ratio analysis is, at that time, we can consider only two or three elements to evaluate the ratios. Whenever decision making regarding any sort of performance analysis of a company of in any nature, it is not sufficient for us to consider only two or three variables related to the decision making by considering to evaluate the ratios. To evaluate the performance of a particular company, we may require so many inputs and so many outputs. The main drawback of this kind of a ratio analysis existing currently is, at a time, we can consider only two or three variables to have a ratio, evaluation of ratio, and according to the ratio, we can analyze whether the company is doing better or the otherwise. But it is a drawback, right? Whenever if you have many variables, many input as well as output variables are available to study, it is not sufficient to consider only two or three restricted to evaluate the performance of a firm. So as a remedial measure or as a hurdle remover, we introduce the concept of data envelopment analysis, which considers at a moment any number of variables, for the study. So it is referred as a DEA. It's a fractional programming methodology to measure the efficiency of multiple decision-making units when the production process presents a structure of multiple inputs and outputs. Why here I mentioned the production process? This particular structure or the methodology was initially introduced majority in production process, then slowly taken into consideration almost a different skill set required for a managerial decision-making situations. For example, in finance, human resource management, likewise. Initially, it was introduced only in the operations management, right? Slowly, it picks up and almost any sort of a performance analysis can be done based on any particular managerial special skills required here. Building on the notions of Farrell, 1957, the pivotal work measuring the efficiency of decision-making units by Charles Cooper Rhodes, 1978, applies linear programming to estimate an empirical production technology frontier for first time. That is, this particular methodology was introduced in 1957 by and continued for conversional and improvement over it And Chauncey, Cooper, and Rhodes introduced a better model in 1978, and slowly it developed. And currently, that we have a lot of improvisation over the methodology. So it's a non-parametric method. We know what is a parametric as well as what is a non-parametric. Okay. It's a non-parametric method in operations research and economics for the estimation of production frontiers. It is used to empirically measure productive efficiency of DMUs. Non-parametric approaches have the benefit of not assuming a particular functional form or shape for the frontier. However, they do not provide a general relationship relating output as well as input. So here, normally in any production process, we have inputs which are required for manufacturing, and we have our own defined production process based on different products and utilized by the process, and as an outcome we have different outputs. So this communicates the input output process. So here what we considered as decision making units. Decision making units can be visualized as manufacturing units, departments of the very big institution like universities, schools, bank branches, hospitals, power plants, police stations, tax agencies, IT industries, cement industries, oil industries, likewise. Here, it is possible for us to study the performance analysis of a specific industry. That is the only drawback of this methodology. That is, if we want to study the university available in India, its performance, or the universities available around the globe based on their own performance, it is possible. But we cannot compare the universities along with the IT sectors. That's the main drawback. So this particular tool is highly helpful to evaluate the performance analysis of any sort of different kinds of industrial cases. But only one thing is what? The study can be implemented at a time focused on only one industry. For example, production industry or IT industry or colleges or universities, likewise. It's altogether, it is going to communicate the performance. Suppose, for example, we consider 10 different universities which are functioning in South India, then we can measure based on different inputs and different outputs how the university is functioning. Among the 10 universities, which university is functioning very well, likewise. The same concept can be incorporated into any sort of a companies. Right? Here, we have to define, according to the nature of industry, what are the different sort of inputs available and what are the different sorts of the output available. It's a must. We have to be very, very clear vision to communicate. Right? What are all the variables available and which one is called as the input and which one is called as the output must be clearly spelled out. Otherwise, we cannot implement this particular methodology. So here, fundamental concepts of efficiency evaluation. The efficiency evaluation is nothing but the efficiency transformation of the different types of inputs into different types of outputs. Mathematically speaking, it is equivalent to the ratio efficiency is equal to total output divided by total input. we have to integrate all those outputs as well as all those inputs and find the ratio. Okay, so efficiency is computed based on total output divided by total inputs. This evaluation of performance measurement based on different DMUs of similar industries. Okay, this study can be implemented in any sort of forms. For example, education, manufacturing, fast food chains, BFSI, healthcare industries, FMCGs, retail chains or retail malls, other industries like. So there is no restriction. We can employ this as a tool to study the performance analysis of the specific industry, and we can come to know whether the company is doing well in the particular industry. For example, if we want to make a study among the universities, we can make and we can come as an out. We can go in for getting a specific outcome stating that which university is doing better in the current scenario. Likewise. So here what the main aim here is going to be, we cannot have a crossover. Universities can be compared with only the universities. IT sector can be compared with only the IT sector. That is a main drawback here. But what is the main advantage? Unlike the ratio analysis, it accommodates many variables, many input variables and many output variables at a time. And while employing those variables for the study, we have to take into consideration a small formula is given. How many inputs and how many outputs can be considered for a better results. Prior knowledge for this particular application required is fractional programming structures as well as linear programming structures discussed in operations research. We know very well, LBP plays a vital role, right? Even though this operations research model comprised of 17 different structural models existing, out of which the initial model was a transportation structure, followed by linear programming structure, etc., etc. But even we have 17 models. Among all the models, LPP plays a vital role. The reason is, majority of the managed decision-making situations, approximately, the study shows, more than 80% of the occasion, when you want to transform the business model into a mathematical model, we require LPP applications. That's why almost throughout the globe, wherever the students are doing operations research as a paper for UG or a PG, we have LPP plays a number one position. Okay, so this applications requires fundamental concepts regarding linear programming and a fractional programming structures, which is available in operations research models. Okay, so before getting into the particular modeling of DEA, I'd like to discuss about very quickly the concepts related to mathematical modeling. Okay, the structure, objective function, one or more conditions, along with the non-negative restrictions are referred as a mathematical model. Okay, if a model comprised of the three characteristics, we call that as a mathematical structure or mathematical model. Okay, many we know the application of linear programming. Here, these elements are called optimization tools because at a time I can go in for either minimizing or maximizing a particular situation. So we know very well in a business arena, we have two main concepts. One is called cash inflow, the other one is cash outflow. Cash inflow is what? Cash is coming in. Cash outflow is going out. So any company is very much interested to go in for maximizing the cash inflow and minimizing the cash outflow. This is the one of the structure of linear model, having a objective function, having a m number of constraints and n number of variables along with a non-negative restriction. This is called a non-negative condition, and these elements are called the constraints, and this is called the objective function. Okay, this is structure, basic structure. So whenever if you are going for modeling, right, almost all the members, those who are online, are listening this particular lecture, you come across the various methodology which is available in linear programming and the methodology of resolving. Okay, so for a classroom study or a nominal explanation purposes, we can have 3 or 4 variables to form a linear structure, and we can resolve manually. We know the various methodology available. We segregate into simplex, then bigger method and two-phase method and dual simplex method. Likewise, we have different methods. Okay, but whenever in real life situation arises, it is not possible for us to consider the real life application of linear programming will have only 3 variables or 4 variables. So we did a lot of projects, right? A lot of PG projects. In one such case, we had 100 variables with 100 constraints. Imagine the case of solvation, right? So manual solvation is not advisable. Okay, it will take a lot of time for us to. We know very well, if you have a m number of constraints, the number of iterations are going to be 2 to the power m. Provided the solution exists, it may go in for what? Maximum of 2 to the power m number of iterations. For example, if you have 100 constraints, think about it, 2 to the power 100 iterations, which is highly impossible for us to manually solve it. So right now, we have many algorithms are available, many softwares available. Right? One such case is Tora. Okay, then we have a Lindo and we have a Lingo. Even we can resolve the linear programming models or operations models using MS Excel. Okay, so here for explanation purpose, we consider a simple model where the linear programming can be employed in the hospitals. Because one of time, I'll explain the model clearly. So suppose, assume that an hospital requires to employ nurses for their day-to-day routine. Okay, so they can engage inpatient as well as outpatients. So here this model requires certain number of nurses to be employed. Okay, employed. So the entire working hours of 24 hours a day is split into 8 slots, 3 hours making a one shift. So the shift starts from 12 to 3, 3 to 6, 6 to 9, etc. Then 9 to midnight. 9 to midnight. Okay. The condition provided as what? In shift 1, the hospital needs 30 nurses. Shift 2, it requires 20 nurses. Likewise, shift last 8th shift, it requires 40 nurses. This is the minimum number of nurses required. Okay, so this is a recruitment problem, right? Suppose when we need only 90 nurses, if you're going for 100 nurses, then we spend extra money as a salary for the 10 more nurses, right? So to overcome this, we want to estimate how many number of nurses required as an optimum number. So here, this model, the model that what I'm going to create for this structure, for this particular situation is, in each shift, how many number of nurses to be employed in each shift, how many number of nurses to be employed. Okay, that is a question to be answered. So for any mathematical modeling techniques, first of all, we should identify what is the objective. Number two, how many variables are involved in this particular model. Number three, what are the conditions one has to look into. Number four, what is the non-negative restriction status for the particular problem. So here the problem is the hospital would like to know what is the exact nurses to be employed or to be recruited in each shifts. The condition provided here, a nurse entered in one shift should work in the second shift also. They should work 6 hours together. For example, if a person enters by 12 midnight, she or he can leave only by 6 a.m. in the next shift. That is the condition provided. So here, because it is a HR model, employment category, we have to spend money for a salary structure. Okay, here we consider what? Cash flows, cash outflows. So any cash outflow should be minimized. So here the objective main is going to be what is the optimum size of nurses to be employed in different shifts. That is objective. So objective is what? Minimizing the number of nurses required overall. Number two, number of variables. So it's a question of employing nurses in different shifts. So 8 shifts, I don't know how many. So I can go into what? Incorporating 8 different variables. Right? Let us take x1, x2, etc. up to x8. 8 different variables. And regarding the conditions here, in each shift that we have what? Require of minimum 30, minimum 20, minimum 40. So we have 8 shifts. In each 8 shift that we have a condition, so we have 8 different conditions available. And let us consider the variables as x1, x2, etc. up to x8, referring number of nurses required in each shift. Okay. So number of nurses required for each shift referred as x. Everyone should be strictly positive. I cannot go in for employing a negative number of people. Right? So objective is minimizing total number of nurses needed. Number of conditions are going to be 8. Number of constraints are going to be 8. And the non-negative restrictions, all variables are positive. So this is the process. Okay, I've already explained to you. These are the questions to be raised before modeling. Right? I've already explained. And we got the answers too. The objective is what? The total number of nurses needed must be minimum. Okay, 8 variables involving, 8 conditions involving, and all variables must be positive, greater than or equal to 0. Okay, so whenever a problem is provided to you for modeling purposes, you have to answer the above said 4 questions. After that, I can go in for tabulating the given information in a proper way in order to make the modeling as what? As simple. So this is a structural information provided. So I have 8 shifts given. Minimum number of nurses needed is provided here. Okay. I am assuming that what? In shift 1, x1 number of nurses are coming in. In shift 2, x number of nurses coming in. Likewise, in shift 8, x8 number of nurses are coming in. Okay. So here it says that when x1 numbers are coming inside by 12 noon, by 12 midnight, then they can leave only by 6 a.m. x2 numbers entering into 3 o'clock in the early morning can leave only by 9 o'clock because the condition provided is what? They should work for 6 hours together. Okay, this is a structure. So we assume that let xj be the number of nurses needed in the jth shift. Okay, we want to minimize the total number of nurses needed. So we are going to incorporate, we are going to employ X1 number in 1, X number in 2, likewise X8 number in the 8th shift. So what is the total? It is nothing but X1 plus X2, etc. up to X8. So this I want to minimize. So mathematically, the objective function is going to be minimize z equals to summation I is 1 to 8 xj. Okay, now let us come into the conditions, right? 8 conditions. So let us fix the conditions for the second shift. What is the condition provided here? In the second shift, see to that minimum 20 nurses must be employed. Now we have to evaluate how many nurses are available here in shift 2. If we know very well, X1 allocated, S1 joined in the shift 1 will be available here. Likewise, X2 numbers employed for this shift also will be here. The total number of nurses available in shift 2 is going to be X1 plus X2. So that X1 plus X2 should be minimum 20, which means that the combination of X1 plus X2 should be greater than or equal to 20. Because inequalities, minimum condition provided, I can use a greater than symbol. Maximum provided, less than symbol. Exactly means I have to make use of an equality symbol. So here what? Minimum in each shift, this number should be available. So in shift 2, X1 number joined with the shift 1, X2 number joined with the shift 2 are available here. So condition is what? X1 plus X2 greater than or equal to 20. Similarly here, in the shift 3, X2 numbers join in shift 2, X3 numbers join in shift 3 available. So X1 plus X3 is greater than 40, all the constraints. So these are all the 8 different constraints possible here for this particular model. So minimize z is summation xj, where j is 1 to 8, subject to the following 8 conditions. And all the 8 variables are positive. So see to that I have 8 different conditions having 8 different variables. The number of iterations may have 2 to the power 8 to get a solution as a maximum number of iterations if the solution exists. Okay, it will take a lot of time for us to resolve manually. So we have a package. Here I've used the package called Torah. The outcome says that in shift 1, employ 30 nurses, recruit 30 nurses. Shift 2, don't go in for recruitment. Shift 3, employ 40 nurses. Shift 4, 10 nurses. Shift 5, 50 nurses. And don't employ 6 as well as X7, 40 nurses. And X8, don't employ anybody else. So this is a pattern of to be selected and to be appointed. Such a fashion overall, I require 170 number of nurses needed. So what this 170 and along with the solution set says that for this situation, this is the only solution available, right? For this situation, this is the only solution available for the situation, which means that this is the only combination, that is 30, 0, 40, 10, 50, 0, 40, 0 being the solution set for the given situations. So altogether, to run the show very clearly, right, the hospital requires 170 nurses exactly. This is the minimum number, right? If we alter this cases, certainly cannot have minimum as 170. Minimum should be more than 170. This is what one of the application of linear programming or operations research model in the hospital industries. Okay, so this model is given for you to understand how the model building looks like. In that case, comparison with the DEA will be easily understandable by anyone. Okay, the previous model, right? The previous model is referred as a mathematical model and also called as a linear programming because here I have the function as what x1 plus x2 up to x8, which is linear because that is the condition of linearity. And here x1 plus x2, which is linear, x2 plus x3, which is linear, likewise all are linear. This model is linear programming model. Okay. Now, when you come into the case of, or when you get into the case of DA, I said already, it's a fraction. Efficiency is what? Total output by total input. Okay. Very similarly, here, we are going to have the concepts related to fractional programming problem. You should know the difference between the linear programming problem and the fractional. In linear programming problem, we'll have a constraint, not as a fractional structure, a normal linear equation structure. Okay. Then here, see, maximize z equals to f of x by g of x. There we had x1 plus x2 plus x, etc. up to xn. Here you may have maximize z equals to x1 plus x2 plus x3 divided by y1 plus y2 plus y3. Fractional. So this is called the objective function and this is called the constraints. So what the methodology says that whenever the objective function alone or one or more constraints takes the form of a fractional structure, the model is said to be a fractional model. Right? So here, for example, I have given the objective function is fractional. Say maximize z equals to f of x by g of x. Maximize z equals to f of x by g of x. So here the objective function is fractional and this is linear. So it is called what? A fractional model. So for solving a fractional model, we have a different methodology. But it is not that easy to resolve a fractional programming model very easily. So what? Here, even though the DA model, the conversion looks into a fractional structure, we are not going to solve the fractional model directly. By using a mathematical concept, we convert the fractional model into a linear model and we are going to solve what? Very easily. Okay. So here in the DA, data envelopment analysis, we have two basic structures. One is called additive model, other one is called multiplicative model. Right? Two models are available here. The same can be solved by using the following ways. Software facilities available for resolving LPP. I said already, Tora, Lindo, Lingo, etc. Now, how to choose the DMUs for the study? Homogeneity of the manufacturing or service sectors. The basic condition is what? The selected DMUs should have homogeneous units. Means IT industry can be studied or education industries or hospital industries likewise. The task and the objective should be similar. The set of inputs and outputs must be one and the same, excluding the differences in magnitude. So homogeneity should be maintained. That's the foremost condition here. Okay. So here, how many companies one can consider at a time for evaluation of similar industries? Darath and Alkeren in 2000-2001 discussed that in order to identify the most effective and ineffective DMUs, one should follow the condition that the number of DMUs should be more than the product of the number of inputs as well as outputs. For example, if you have number of inputs 2, number of outputs 3, 2 variables and 3 variables. 2 3s are 6. So the number of companies for the study should be minimum 6 and above. So even the DEA literature reveals that a lot of studies were made with the small sample sizes. The size of the sample should be twice or thrice more than the sum of the number of inputs and the outputs. Say, for example, if you have 2 inputs and 2 outputs, 2 plus U1L1 plus U2L2, U3L3, etc., up to ULIL, being the total inputs of the particular study. Likewise, the outputs, we have N outputs, we consider OK being the output, means what? O1, O2, etc., ON. And V1, V2, etc., PVN being the corresponding weightages. So Vk, OK being the overall value corresponds to the kth DMU as an output, kth output variable. So when you add everything, when you add all the values, we have V1, O1, V2, O2, etc., Vn, On being the total output. Okay. Now the efficiency. It can be defined as a ratio of virtual output over virtual input. The same can be given as efficiency equals to output divided by input. That is summation k is 1 to n Vk OK divided by summation j is 1 to L Ui Ij. It is obvious that the efficiencies of all the DMUs should lie in the interval 0 to 1. That is, here we consider the maximum efficiency as 0. That is what? Max efficiency as 1, the minimum is 0. The efficiency always lies in the range 0, 1. If the efficiency, what we evaluate, is closer to 1 or exactly 1, we say the particular firm is doing extremely very well. Or that is a concept. So the efficiency rate always closer to 1. If it is 1, highly satisfied. So this is the formula to evaluate the efficiency. So DA model, I'm going for a fractional. So these are the notations. I'm considering n number of companies, capital N number of companies. Right? Going to build a model for the mth DMU. Right? The company is what? Mth company, for which I'm going to write the constraint. Or I'm going to write the corresponding problem here. So this is the name of the objective function, efficiency of the mth company. O be the output variable, I be the input variable. Okay, these are the notations. EM being the efficiency of the mth company. So this is the structural formula. So this is the overall output for the corresponding mth company. OKM being the output variables, where M refers the company, K refers what? The variation. I have n companies, right? So O1M, O2M, etc. ONM being the variables. Here V1M, V2M, etc. VNM corresponding to the weights. So multiply VKM into OKM, where K is 1 to N. Likewise, the total input. So this is a total output divided by total input. I said this efficiency level, this is a mth company's efficiency. So where what? What is only for M? M is varying from 1 to N, because I consider what? N different companies. So M takes value 1, 2, 3, etc. up to N, capital N. This efficiency can be minimum 0, maximum 1. So that's what we have here. This efficiency value is always lies between 0 to 1. So this is objective function subject to this condition, where all the variables, right? Where all the variables, the weights that we are going to evaluate, right? VKM, UJM, all are positive here. All are positive. See to that this this is a structure of a fractional model. When a model is said to be a fractional model, if the objective function or one or more constraints are both taking a fractional value, we call that as a fractional programming problem. I said already, this fractional model can be solved with a little difficulties, right? So it is a tedious methodology is available to resolve. So to make the things easy, we want to convert this fractional model into a linear model by means of a small assumption, by means of a very small assumption. I can give 1 minute time for the participants can visualize how this function, how this fractional model can be put into a linear model. So what is the difference between a linear and a fractional model? In a linear model, no fractional value should come. Okay, here what I have a functional type f of x by g of x. And here also I have f of x by g of x. So by using a simple assumption, we should convert this into a normal structure, linear programming structure. So you can take 1 minute time to think it over. The concept is very simple here. Assume that this denominator value as 1, the summation of this entire value as 1, and put that as a condition here in the objective function, right? Put as a condition in the constraint model. Okay, in that case what? Becomes very simple. You assume this as this denominator as 1, okay, and put as a condition in the condition area. And here this, you can very well ignore this 0 value. You consider this alone. You can cross multiply. We have summation k is 1 to n, vkm, okm less than or equal to summation j is 1 to l, ujm, ijm. If you take the right hand side, right hand value to the left hand side, right becomes 0. Right. So it becomes a linear. And when the moment this becomes 1, objective function becomes a linear. And along with the condition, this you have to say summation j is 1 to n, ujm, ijm should be 1 as a condition. Is it okay? That's why that I can make use of as a simple model. The current DEA is about a fractional, which is so complex to solve directly that I've already explained to you. The same can be converted into an equivalent like as a model with a simple normalizing procedure. But this is a conventional model. See the additional condition? Summation j is 1 to l, ujm, ijm is 1. When the moment this becomes 1, this becomes a normal objective function. Okay? And cross multiplication and taking to the left hand side becomes a very simple linear programming structure can be resolved using any one of the packages. So this is an equivalent model. This is a corresponding conventional structure. Okay, here we consider one particular situation, right? I'm going to construct a model, or I'm going to study 5 different institutes. Among the 5 different institutes, which one is better? Likewise. So for the study, we need some inputs and some outputs. In order to explain the model, I'm considering a limited inputs and limited outputs and limited number of companies for study, right? So I'm considering 5 different institutes, institute A, B, C, D, E. And the output is what? Number of students passed. We have many outputs, right? For easy explanation, I'm considering what? Number of students passed. So output, I'm saying O, right? Because only one, I'm considering what? O1 being the one output for this case. As input, I'm assuming number of students admitted and number of faculties recruited. This is input 1 and this is input 2. Right? This is the data. This is the data. Right? Let us consider the weightages for output 1 as x1, output for input 1 as x2, input 2 as x3. We can use any sort of notations. You not have a very clear and simple case that we make use of what? X1 being the weight for the output 1, x2 being the weight for the input 1, and x3 being the weight for the input 2. And this is the data. Number of students passed, number of students admitted, number of faculty recruited. Right? Here, for every model, for every institute, we can construct the efficiency. What I told you, the efficiency is nothing but total output divided by total input. Okay, let us construct the efficiency for the company A, right, or for the institute A. Notation E suffix A. So the output is this one, input is these two. So here the overall output is what? 1163 times x1. Here 4434 times x2 plus 344 times x3. So what is the overall output here? 1163 x1. That's all. Because I consider only one inputs. Then here it is 4434 x2 plus 344 x3. Okay. So the efficiency, the formula here, right? This is a structure. Using the notation, I'm simplifying the notation. I'm not interested to go in for V1B, O1B, right? It is simplified. Okay. We have here the simplified versions. 1163 x1 divided by 4434 x2 plus 344 x3. Right? This is for the company, for the institute A. Right? Let's consider the institute B. It is 149 x1 divided by 5662 x2 plus 513 x3. Likewise, I can construct for all. Okay. So this is the corresponding efficiency rate for institute A, institute B, institute C, institute D, and institute E. Okay. Now for the study, we have to construct the fractional model for every individual institute. For A, for B, for C, for D, and for E separately. So we have to go in for 5 different structures must be created. So whenever for the model A, whenever if you're creating the DA model for A, for institute A, it is maximizing, right, this value. Maximizing EA equals to 11631 divided by 4434x2 plus 344x3 subject to all the conditions less than or equal to 1. That is the model for institute A. Mind it, for the institute A, use EA as objective function. For B, use EB. For C, use EC. For D, use ED. For E, use EE. So the problem number 1 for A, for institute A is maximize E suffix A equals to this value subject to this value is less than 1, 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 and this value is less than 1, where x1, x2, x3 positive. So we can look into one structure for A. So this is kindly go through. This is the one such column referring A. Likewise, I have to create 5 problems. Okay, solvation is not that easy here directly. So we'll make an assumption. Right? We'll make an assumption. This 434x2 plus 344x3 equals to 1. We'll make an assumption. Right? We take this as a 1. This reduces to maximize EA 1163x1 subject to 4434x2 plus 344x3 which is equal to 1. And here just cross multiply and take all to the right side. This is a structure for the first problem. Right? Likewise, create for all. Likewise, create for all. Similarly, one can construct a fractional DEA for all other institutions B, C, D, and E. The current DEA is about a fractional programming which is so complex to solve directly. The same can be converted into an equivalent like a model with a simple normalizing procedure. Firstly, one can normalize the denominator of the objective function of the fractional program which evaluates. Okay, so this is a conventional structure. This can be solved by any Torah or Lindo or Lingo or Excel, right? Or even manual, right? This is a Torah output. Communicates the weight for x1 is 0.004680. The weightage for x2 is 0. Then weightage for x3 is going to be 0.002970. The efficiency is only 0.5442483. So the efficiency is what? Approximately 0.55, only 58%. Which means what? The institute is not doing exactly well. That's the meaning. So we choose the highest efficiency as a best. If it is 1, we say it's a perfectly, we can say highly efficient. We can say highly efficient. Okay, likewise, we have to do for B, C, D, etc. and compare. So this, I have a solution of the 6th iteration using a Torah package. You can resolve using anything, right? Lindo, Lingo, even MS Excel, likewise. This is the outcome. The efficiency is what? 0.544248, which is not sound, which means that it has to get into all aspects and to evaluate which area they should concentrate in order to improvise. Okay, so this is an example. We have to do what? EB, EC, ED, EE, 5 models. Then you have to resolve and you have to evaluate and you have to choose the best. If it is exactly one, we say it is highly efficient, or at least a closer to one. Okay, so this is what a basic example wherein which one can think of applying the DEA structure. Okay, so as application case, assessing the efficiency of a quality of living condition among the Asian countries using data envelopment analysis. Even this can have a part of a big data analysis. When we take a larger number of inputs and outputs and a larger number of companies for study, right? So here, before getting into any study purposes, identify the which industry you are considering and look into all possible inputs and outputs, and the region for the study must be fixed. At least you have to study 5 years or 7 years to have a clear-cut vision. And deciding regarding the number of inputs and outputs is required. High experience is needed. Okay, when number of companies are more, a number of variables, number of inputs and outputs are increased, this can be visualized as one of a model comes under a big data analytics. People majority they call, can we consider this as a multivariate analysis? The answer is yes. In statistics, we have a multivariate analysis, right? So it's very similar. It is very similar. Okay. So here we see one more example, a live example of assessing the efficiency of quality of living condition among the Asian countries using DEA. So this is one of our research study. The aim of this research work is to investigate and examine performance efficiency of some of the Asian countries in the world individually and identify the better countries. Design or methodology. For this study, researcher considered only 15 Asian countries and collected secondary data for the years 2013 to 18 from the website numvo.com of individually, then considering 4 input and 2 output variables. The data envelopment analysis technique have been employed. Findings. Study reveals India, Indonesia, Japan, Singapore, and UAE attains the top position among all the countries. Okay, we considered 15. The another drawback is when you fix the number of inputs, number of outputs, for all the DMUs considered for studies, all sorts of inputs and outputs should be available. We may face some problem. According to the availability of the inputs and outputs, the number of DMUs should be reduced. There is no other go based on the majority availability of inputs and outputs. So these are all the 15 countries out of 48. Although we have 48 Asian countries, we consider only 15. This is the countries considered. period 2013 to 2018. These are the input and output variables. We have 4 inputs and 2 outputs. So 4 2s are 8. Number of countries are 15. So 8 is more than 15. It is valid. A number of inputs, number of outputs is validated here. Cost of living index, local purchasing power index, groceries index, pollution index, quality of life index, safety index. So 4 inputs and 2 outputs. So this is a data collected from the website. Outputs are named as O1, O2. Inputs are named as X1, X2. Sorry, I1, I2, I3, I4. For conversion purpose, you can use the output as X1. X1, X2 as outputs and X3, X4, X5, X6 being the input variables. So here, suppose we use X1, X2 and X3, X4, X5, X6, the efficiency of China, right? Efficiency of China is nothing but 31.5 X1 plus 73.13 X2 whole divided by 60.72 X3 plus 37.27 X4 plus 66.43 X5 plus 89.35 X6. That is one problem. Efficiency, maximizing E suffix China, right? Referring China is nothing but 31.5 X1 plus 73.13 X2, right? Divided by 60.72 X3 plus 37.27 X4 plus 66.43 X5 plus 89.35 X6. Similarly, we can go in for efficiency for India. 73.7 X1 plus 57.88 X2 divided by 30.24 X3 plus 61.92 X4 plus 32.5 X5 plus 77.48 X6. Okay, we can construct a problem for India. Okay, this is a problem for India. Mind it, 15 countries we have, right? 15 efficiency ratio that we should have, right? Some more is missing, some more will be in another slide. So, maximizing E suffix India, efficiency for India, this is subject to all the ratios less than 1. Okay? Some more conditions, right? Corresponding LPP structure, you put this entire value as 1 denominator as a condition. You cross multiply and simplify. Okay, we have this. Fifteen equations, right? 15 constraints. The first one is an equation because what? We assume the value is 1 in order to convert this into a normalizing process. So 6 variables, 15 constraints. Manual solvation may take hours together. Repeated computations may lead to error. So better using softwares. Right, this is the outcome. This is another similar structure, variable rotator scale model, right? And this is a corresponding model here. And this is the outcome for constant rotator scale. Here we are going for 2 different structures. In constant rotator scale, whatever be the modification done for a variable, the outcome is same. Variable rotator scale, according to the changeover, there will be a changeover in the outcome. That's the meaning. So all the 15 types of problems solved, right, for 15 countries, and this is the outcome for the year 13, 14, 15, 16, 17, 18. You see, for India, all the values are 1. So aggregate is going to be 1. So this aggregate communicates which one is the better one. So India is 1 better, Indonesia is better, then Japan is better, then Singapore is better, then UAE is better. So when value is 1, we say it is highly efficient. Right? When value is 1, it is highly efficient. Likewise, we compute for variable structure. Here also you can say India is 1, Indonesia is 1, Japan is 1, Pakistan is 1, Philippines is 1, and South Korea is 1, sorry, Singapore is 1, and UAE is 1. The same, so the same value evaluated is in the package. So this is a comparative cases, CRS and VRS. Take an average of these two to conclude. So here what? India is 1, Indonesia is 1, Japan is 1, Singapore is 1, and UAE is 1, which communicates among the 15 countries considered, which one is highly efficient for living conditions or better one for the living conditions, that we have India, Indonesia, Japan, Singapore, and Dubai. This UAE are the better one. That is a final conclusion. Okay. So likewise, one can fix the area, fix a company or fix the industry, and fix the inputs and outputs, and we can go in for elaborating. Right? Okay, this is the structural view how the data envelopment analysis can be employed in a smaller level or a bigger level. We can go in for utilizing one such model for big data analytics as a model. Okay, so with which that I'm concluding. Any queries, please? Thank you very much for your patience listening. And once again, I thank you, the organizer, especially Dr. Shanmuguri ma'am, the chairperson for this particular event. Thank you, ma'am, and thank you one and all. And thank you very much for all the organizers for providing me the golden opportunity to share my views regarding this data envelopment analysis as a new tool available in the hands of big data analytics people.